Module 5.2, Critical Band, Bone Conduction, Threshold of Hearing and Pain. The critical band. We mentioned before that different frequencies stimulate different parts of the basilar membrane. High frequencies cause hair cells towards the base of the cochlea to fire, whereas low frequencies cause the hair cells at the apex of the cochlea to fire. Each hair cell has a specific frequency that it is sensitive to. That frequency is referred to as the characteristic frequency, or CF. Now, it turns out things are not quite as simple as that. Rather than just responding to a single frequency, each hair actually responds to a range of frequencies. If we look at a frequency response of the hair cell, we will see that it will react to a large range of frequencies below its CF, but not above its CF. If frequencies are far apart, different hair cells will sense each sound and send information to the brain that there are two separate frequencies. As two frequencies get close together, it gets harder to distinguish them as two frequencies because the sensing range of cells starts to overlap. This is similar to what happens on your skin. If you press two fingernails into your palm about a half-inch apart, you'll feel both fingernails. But if you put them about an eighth-inch apart, it will only feel like one. When the two sounds are close in frequency, we no longer hear them as two sounds, but rather one sound that is either harsh or wavering. We call the range where two frequencies go from sounding like one to two different sounds as the critical band. This is where there is considerable overlap between responsive hair cells. The musical interval at which this occurs is between a major and a minor third, or about a third of an octave. Listen to this demonstration of the critical band from Total Recording by David Moulton. What you will hear are two simultaneous tones. At the beginning, when the two tones are less than 15 hertz apart, it sounds like a wavering tone. Then, between 15 hertz and the critical bandwidth, it's a rough-sounding tone. Once it exceeds the critical band, you will be able to distinguish two separate tones. The critical band has many ramifications that we will discuss throughout the course. The important information to understand now is if two sounds have a frequency difference that is within the critical band, they will sound like one sound. If two sounds have a frequency range that exceeds the critical band, they will be heard as two sounds. Bone conduction. Do you remember the first time you heard a recording of your own voice? I'll bet you were thinking, that's not what I sound like. Well, there's a very good reason for that. In this course, we're mainly learning about sound that travels through the air. When you speak to someone, they're hearing your voice because the sound waves travel through the air. But when you speak, you're hearing your voice two different ways. You are hearing the sound waves of your voice travel through the air to your ears, but something else is happening. Put your hand on your face underneath your ear so it is touching your jaw and your throat just under your jaw. Now hum a note. Do you feel that vibration? Well, it turns out that vibration causes your skull to vibrate. And if you remember, the cochlea is embedded in the bone of the skull. The vibration from your voice travels into the cochlea, along with the sound traveling through the air, and they are combined. The sound caused by the vibrations from your skull is called bone conduction, and it makes you think your voice is deeper and richer. Sorry to disappoint you, but the sound of your voice on a recording, that's the real sound of your voice. Threshold of hearing. The threshold of hearing is the smallest change in sound pressure that we can hear. If you remember, pressure is measured in pascals, or newtons per meter squared, and 1 pascal is the pressure exerted on your arm by $1 bill. The pressure that causes the softest sound we can hear is 2 times 10 to the minus fifth, or 0.00002 pascals, at a frequency of 1 kilohertz. That is an inconceivably small change in pressure, yet someone with good hearing can hear it. Threshold of pain. The sound pressure recognized as the threshold of pain is about 20 pascals. That is equivalent to the sound of a nearby jet plane taking off. It is not the loudest sound we can hear, but it does cause physical pain to the listener. In this course, the limits of sound pressures for sound that we will consider will be 2 times 10 to the minus fifth to about 63 pascals. If your answer to a problem in this course is outside that range, you have made a mistake. To review, the critical band is the frequency range where hair cell responses overlap. If 2 sounds have a frequency difference that is within the critical band, they will sound like one sound. If 2 sounds have a frequency range that exceeds the critical band, they will be heard as 2 sounds. Bone conduction is the auditory stimuli caused by vibrations in the bone. The threshold of hearing is the smallest change in sound pressure that we can hear, about 2 times 10 to the minus fifth pascals. The threshold of pain is the change in sound pressure that begins to cause physical pain, about 20 pascals. The range of sound pressure that we will use in this course is 2 times 10 to the minus fifth to about 63 pascals.